true, false. If x and y are perpendicular, we're going to call vectors orthogonal. The dot product of x transpose y is equal to 0. And we're given a little figure to help us decide this. Because of the figure, I suspect it's true. So let's try to prove it. I'm going to approach this one a little differently because I'm going to, before I start my proof, write down some information that might help me. Now notice through the picture that if x and y are perpendicular, that means the picture here with the vector x, the vector y, and the vector x plus y form a right triangle. And what do we know about right triangles? We know that if we think of this as having length A, this side as having length B, and this side as having length C, then by Pythagorean theorem, a squared plus b squared is equal to c squared. We know some other things though. We know that if this is vector x, the length of it, or a, is the 2 norm of of x. So if you square it, we know that's the dot product of x transpose x. We also know if you square the length of y, that is y transpose y. We also know that if you look at the length of x plus y and square it, that should be the dot product of x plus y with itself. Now what else do we know? From Pythagorean theorem, if we looked at c squared minus the quantity a squared plus b squared, the result should be 0. So if we have vectors x and y that are perpendicular, what we want to do is look at, for my proof, we want to look at the length of the sum squared and subtract from it the length of x squared and the length of y squared. And we know our result should be 0 by Pythagorean theorem. Since these are supposed to be perpendicular, so they form a right angle. Now, what do we know about these lengths? Well, here we have the inner product of x plus y with x plus y. And this is going to be the inner product of x with x, and this will be the inner product of y with y. If we perform the arithmetic here, we should get 0. We're going to say that this expression is equivalent to this expression. And the symbols I usually use are triple lines. It means for every x and y that make this true, it's also going to make this next expression also true. Anything that makes this false is also going to make this false. So these two expressions are equivalent to one another. And the reason I know that is the definition of length in terms of dot product. Now, what do I have here? In the last unit, we determined that the dot product of x plus y with x plus y is the dot product of x with x plus 2 times the dot product of x with y plus the dot product of y with y. So we can expand this term. We still need to subtract the dot product of x with x and also subtract the dot product of y with y. The result should be 0. And this is just by one of the homeworks in the previous unit. Now, if I do some arithmetic here, what I end up with is, well, let's see, we have the dot product of x with x as one term, and also over here is another term where we're supposed to subtract. And we have the dot product with y with itself minus the dot product of y with itself. Those two will be 0. When we perform some arithmetic, because remember each one of these terms is just a real number, we end up simplifying the expression to 2 times the dot product of x with y must be 0. But again, doing some arithmetic, we can divide both sides of the equation by 2, and the result will be that the dot product of x with y must be 0. So we've shown that if x and y are perpendicular, that means they form a right angle, it is going to be true that x transpose y is equal to 0.